Okay, so the next video is going to be walking through a scenario, and we're specifically going to do the type 1 error first, but we kind of have a recipe, and I want to look at the recipe. So first off, we have our definition. Type 1 error, the probability of rejecting the null given that it's true. All right, rejected the null given it was true. Another way of saying it, we rejected the hoe, but it was a mistake. Because HO was true. All right, we'll just leave it at this. We rejected the hoe, but it was a mistake. All right, now notice the very first word is reject. Okay, so type 1 goes with the rejection. Type 2, on the other hand, the probability of failing to reject the hoe. So in other words, we believed the hoe, but it was a mistake. Now, type 2, fail 2, all right? And our decisions are either going to be, when we run a hypothesis test, we either reject or we fail to reject. If we fail to reject, the only type of error we can make is a type 2. If we reject, the only type of error we can make is a type 1. All right? So whenever we are doing a test or we're going to sit there and go, hey, what type of error might we have committed? We need to write down our null and alternative. Then we need to define our parameter in context. And then we need to write the p-value, etc. And then we have to make our hypothesis test decision. If it's less than alpha, we reject the null, and we're going to go this direction. And once we're in this column, we never cross to the other column. On the other hand, if the p-value is greater than alpha, so here we have the less than alpha, here we have the greater than alpha. If it's greater than alpha, then we fail to reject the null, and we're going to go all the way down this column, and we'll never leave that column. And that's going to be the steps that we need to follow. So let's go look at a scenario and put it in context here. It's kind of a long scenario. A researcher wants to conduct a study to test whether listening to soothing music for 20 minutes helps to reduce diastolic blood pressure in patients with high blood pressure, compared to simply sitting in a noise-free environment for 20 minutes. 100 patients with high blood pressure at a large medical clinic are available to participate in the study. The null hypothesis for the study is that there is no difference in the mean reduction of diastolic blood pressure for the two treatments, and the alternative hypothesis is that the mean reduction in diastolic blood pressure is greater from the music treatment. So the null is that there is no difference between listening to music and sitting in a quiet room, and the alternative is that the mean reduction is greater for music treatment. In other words, the music treatment helps more than sitting in a quiet room. And in this particular case, excuse me, I have this in the wrong order. I don't want to start with this one. I grabbed the wrong sheet. I want to start with, we have a p-value. Well, we're going to have to pause this for just a moment. Pausing for station identification, and here we go. We have a p-value of 0.0017. All right, so this is a pretty small p-value. So it says, explain what type of error may have been committed along with its consequences. Well, a null is we happen to have two things. We have mu1 and mu2, and we can say mu music and mu quiet room, and we just start off with their equal. Now, I know we haven't done two samples, but it shouldn't be that big of a deal. And then the next one is mu1 music is greater than mu2. And you're like, well, how do you keep those straight? mu1 equals true population for listening to music, and mu2 equals the true population mean for a drop for sitting in a quiet room. All right, so mu1, pressure drop for listening to music, mu2, pressure drop for sitting in a quiet room. So this is saying the pressure drop of listening to music equals the pressure drop of sitting in a quiet room. This says pressure drop for listening to music is greater than pressure drop for sitting in a quiet room. Doesn't matter to me which order you go in, but it usually helps to work with a greater than sign and swap things to make it fit. But that's up to you. All right. So it's you define the order. So a p-value of 0.0017 is less than alpha equal 0.05, because when you go p-value, and then we say alpha, we have 0.0017 and 0.05. This is less than, and because it's less than, we reject the null. Okay, and so once we go, all right, we rejected the null. And the very first thing on our recipe said, and by the way, I just need to go back and say that we're following the order of that recipe, which I put in a spot that I now can't find, of course. So the very first thing on the recipe says, write the hypothesis. Well, we did that. The next thing said, define the parameters. We did that. The p-value, we did that. Then we said, oh, we reject because our p-value is less, so that's the first thing. Then the next thing, if you reject a null, the only type of error that we could have committed is a type 1. So we just wrote that down. All right. The next thing we do is we write the definition for type 1. A type 1 error is the probability of rejecting the null given that the null is true. That just lets people know that we knew the definition. All right. This is just writing the definition. The next thing says cross out the null. All right. We're going to cross it out, but it was the truth. All right. We are going to circle the alternative. This is what we believe, but it's false. So the consequence, we believe the null, we believe the alternative. So we believed that the pressure drop was greater for music than for sitting in a quiet room. And we started paying for and playing music. But this was an error. Like, well, how did I get that from here? We believed this, so what did we do? We believed this, we believed that the pressure drop was greater for music than sitting in a quiet room. And as a result, we said, hey, we're going to play music. That's what we did. Right? You're going to have to fill in that blank. Then we're going to say, but that was an error. That was an error. And the consequence is the clinic is going to be playing music for patients, and it wasn't any more effective than sitting in a quiet room. Or the consequence is we were paying for music, and it really didn't work. It really wasn't any better than the other choice. All right. So you're going to have to be kind of creative with this. All right. But we're going to start with where we believe the alternative. We believe that the music was better than sitting in a quiet room. And what did we do? We decided to play music, but that was a mistake. And the consequence is we paid for something that really wasn't any more helpful. Okay. All right. So that's working down on the right side of the recipe. Working down on the left side of the recipe, we're going to have the same scenario. We're going to work exactly with the exact same scenario. But in this time, so I'm not going to reread it. Our p-value is a big p-value. We have a large p-value of 0.247. So we need to explain what type of error. Well, the very first thing we do is we write down, the null hypothesis. In this case, the null was that the playing music equaled sitting in a quiet room. Playing music had a greater drop in blood pressure than sitting in a quiet room. Then we define the parameters. Well, same definitions we used before. All right. And then we're going to write the p-value. Well, our p-value is, in our case, our p-value is 0.247. And if we were doing this like a hypothesis test, we go p-value 0.247. We have alpha 0.0500. This is greater. So our decision would be fail to reject. All right. If the p-value is greater than alpha, we fail to reject. So now we're in this column here. So we're going to work in this column. And we're going to start off with, well, if you fail to reject, the only type of error that could have been made is a type 2. All right. So if we fail to reject, the only type of error that we could have made is a type 2 error. Gosh, straight off the recipe. Then we have to write the definition for type 2 error. There it is. The probability of failing to reject the null given that the null is false. So then we're supposed to circle the null. So we circle this, and we believe that it was false. All right, we're going to cross out this. In other words, we don't believe, and this was the truth. All right. So what we believed is they were equal. All right. We believe, and you can say that instead of saying there was no difference, you can say believe that listening to music and sitting in a quiet room were equally effective in listening when we played the music. Okay. But we believed HO. So we believed HO that playing music and sitting in a quiet room had equal effects on blood pressure. All right. And as a result, what would you do? Well, if we believe they have equal effects, I'm not going to I'm not going to pay for the music. So, and did not play the music. But that was an error. And the consequence is the clinic would not provide music which would have lowered blood pressure. All right. So we believe that there was no difference. So we believe the null that there was no difference in listening to music and sitting in a quiet room, or listening in a quiet room had equal effects on lowering blood pressure, but that was an error. And the consequence is the clinic would not provide music which would have lowered diastolic blood pressure. All right. So basically, the patients missed out on an effective treatment of listening to music, if in fact that was the case. All right, that closes that video.